Factor the expression by identifying the GCF, or the greatest common factor. So when we think about finding greatest common factor, I make a rectangle. Sorry about that. I make a rectangle around, and I think about the expression that I gave you as the inside of our area model. Okay, it's the inside of the rectangle. This is the area, and we're looking for the factors, or the length and width of this model. So we need to think about what's the greatest common factor. First, I'll look at the numbers, 16 and 12, and think about what number are both of these numbers divisible by. Well, both numbers are divisible by 4, okay? Is there anything higher that they're divisible by? Well, 12 is divisible by 6, but 16 is not divisible by 6, right? 16 is divisible by 8, but 12 is not divisible by 8. So the highest number that they're both able to be divided by to get a whole number is 4. Then I'm going to look at the variables, okay? So I have x to the third power and x. How many variables can I factor out of both of these terms? Just one, okay? The second one just has one x that I could factor out. So I'm just going to factor out x. I can't factor out any more variables than that. So my greatest common factor is 4x. Now that I have the greatest common factor, I'm going to think about the other factor. I'm going to think about what's going to go on top of this rectangle so that it'll multiply back to the numbers that I have inside. So looking at 16x to the third power, I know if I put 4 here, 4 times 4 is going to multiply back to 16. And if I put x squared, the x to the second power and x to the first power multiplies back to x to the third power. Then I'm looking at 12x. What do I multiply by 4x to get 12x? Well, that would be 3. So now if I ask you what the factors are for this expression, I'm looking for the outside numbers. The outside numbers are the factors, are the terms that we multiply to get the inside numbers, the product. So the factors would be 4x and 4x squared plus 3.